Energy is needed for all things. Our bodies get energy from food. We cook our food using gas. Food reaches the grocery store using diesel fuel. We eat in front of the television, which runs on electricity. Everything in modern civilization requires energy. We want energy to be cheap. We want energy to be reliable. We want energy to be safe, and we want it to be clean.
Meet Dr. Peter Schubert, a professor at Indiana University, Purdue University, Indianapolis, and the director of the Richard G. Lugar Center for Renewable Energy. Dr. Schubert has some valuable insight into the future of energy as it is and what it could be with his satellite design.
Energy is everywhere, and yes, there's plenty. Naturally, we want to use energy sources that are easy to work with. Historically, that started with wood and with hydropower. Then we found coal, and that fueled the Industrial Revolution. As the use of coal became more widespread, some of the environmental consequences became more apparent. Our society needs to move to cleaner sources, renewable sources, if we are to remain viable and sustainable for future generations.
Imagine that by the year 2039, 22% of the globe's entire power consumption is fueled by the sun alone. Sound impossible? The idea may be more plausible than you think. Using a combination of wireless power transmission and solar energy through a satellite module, the future of energy is looking brighter and cleaner than ever. You may be asking yourself how a satellite can lead us to the future of energy consumption. It seems more like a concept you'd see in a Star Trek movie, not a valid idea for the real world. Well, it is an idea that has been out there for almost half a century, but has not made significant headway since then. Our goal is to show people the potential of this technology and how it can be utilized in small-scale applications for our daily lives. Enhancing people's minds to visualize this technology scaling up from stationary facilities to moving objects around a beaming antenna and ultimately to space solar power applications. The initial steps to make this concept reality would be to start with peer-to-peer stationary wireless power transfer in between facilities. Let's look at how these two buildings are interacting using wireless power transmission. This building on the left is connected to a solar panel. The solar panel absorbs the sunlight, generating solar energy. That's how this building is powered. In the meantime, the building on the right is connected to a few wind turbines. This allows wind energy to be generated, powering that building. Because the two antennas are mounted to the top of both buildings, wireless transmission between the buildings is achieved. Once this technology has started to prove itself, accumulate credibility, and gain a following of researchers, it could tackle its next roadblock of beaming power to moving targets. Imagine being able to charge an electric car while traveling down the road. Small antennas can be placed at specific locations, such as billboards, streetlights, and traffic lights. Those antennas, which are powered by solar fields, can beam power to electric vehicles passing by. This application would take us to the next level of energy sustainability and meet power demands of electric vehicles, which are constantly increasing in number. The next market this technology will reach is airborne vehicles such as blimps, aerostats, and drones, increasing the capabilities of unmanned aircraft. This gives us the option of keeping the aircraft flying for an indefinite period of time. Businesses that employ unmanned aircraft would be able to offer services 24/7 without having to worry about interrupting work to recharge. As the range and capability of this technology continues to improve, wireless power transfer from space becomes more feasible. It sounds like a good idea, but you may be asking why the technology isn't already being developed.
There are many approaches to space solar power. Most suffer from one or two showstoppers. A showstopper is a technology that will cause so much problems that the whole thing won't work. So if you can address the showstopper and get that to work, then the whole thing falls into place.
There are three main showstoppers, or problems, that are obstructing the development of this technology down the pathway to power. The first problem is that the method of wireless power transmission creates signal interference. While it is in transfer, the main beam of power creates ripples that emit off of the main beam. These ripples, while negligible in comparison to the main beam, are much stronger than other radio waves used for communication on Earth. This means that they would completely overpower the radio waves we use within their range and knock out our communication systems. The next problem is one of moving parts. In order for a power beam to make constant contact with the receptor site on Earth, the satellite must somehow rotate. All designs for the satellite so far have proposed moving parts on the unit itself. The problem is, it's nearly impossible to keep a constant electrical current flowing through the satellite when its parts have to move or rotate. The last problem is a thermal management issue. The satellite solar panel is constantly exposed to sunlight and thus will collect heat and get very hot. Somehow managing and expelling this heat is the last showstopper standing in the way of bringing this technology into reality. Is there a way around these showstoppers? Have we found a solution?
I have. The Tin Can solar farm has no moving parts. It has integral thermal management and has inherent structural integrity using centrifugal force. If built from resources on the moon or from asteroids, it has the potential to be less expensive than current sources of electrical power.
So what's next?
Space solar power, if we look at the long term, will probably require a consortium of governments and large corporations. So it's important for us to have international participation in this. It's important that our government funds the research needed for the many different technologies that all need to be brought together for such an ambitious undertaking. If we can get the risks down to the point where the private sector of investment can say, this looks feasible to us, then we created a new business with lots of jobs, with a lot of benefits to the environment, and it's available to everybody because we're putting this in orbit around the Earth where everyone can have access to it. Space solar power has the potential to be the ultimate answer for the energy needs of mankind for all time to come.